the B vector on the A vector?
I don't know, we'll throw it down. V of B on the A, the same thing as V as, I forget how they did how they did the letters, but. Alright, so.
B of C.
B of C.
A of C.
Right? No. Let's see it. We have the plane relative to ground.
Yeah.
Is the same, is equal to
Plane
the plane
relative to
relative
air.
to the air.
And air relative to ground.
Plus the air relative to ground.
Yeah.
Right? That's what it should look like. So if I want to find, so using vectors, if I want to figure this out, right? And I want to add, so if I want to figure out what is the velocity of the plane over ground, I add up these two vectors. Right? So geometrically, if I want to add these two vectors, I would take this vector, move it over here, it look like this. Knowing that that's 30 degrees. And then I do something like that. Alright? With that being your answer. So your answer would be geometrically, if you can figure out the geometry, your answer would be whatever the length of that vector is and whatever this angle is, if you're relating it to east, this would be your answer. Okay? Now the question is, sometimes it's easy to do it algebraically, sometimes it's easy to do it geometrically. Right? Like this particular problem, is it easy to do geometrically? Can I figure out the length of this line and this angle?
There's no right angle.
No right angles, but if you knew the law of sine, and what things do I know? I know the magnitude of this line right here is 100. I know the magnitude of this one is whatever, let's say 10. Alright? Now, could I find the magnitude in this? Yeah, I could. You guys haven't done this because you have to look at the law of sines and law of cosines. Right? We already talked about that level of trig. Right? Because I could use the law of sines and law of cosines to figure this out. Right? But we're not going to do that. Alright, that's a little more different. Huh? Yeah. Because I haven't talked about that in this class. So that's like, the law of sines and law of cosines is probably Calc 2 or something like that. Alright, so we're going to talk, and if you guys take my statics class, we'll talk about that more in statics. Alright, but you should, has anybody heard that before? Law of sines, law of cosines?
He makes us do that.
I mean, in trig, you also do it too, because you're talking about, basically, you could use the opposite of rotation and then just solve for it.
No, I'm not talking about SOHCAHTOA.
You're not talking about that?
No, I'm not talking about the sine is opposite over hypotenuse and the cosine is this. I'm not talking about that.
You're talking about like the angles and sides.
Yeah, I'm talking about,
Like an actual trig.
yeah, if you know 2 to 3, you can get it. Right? So there's a law of sines and there's a law of cosines. Like I think the law of sines would say 10 over the sine, and this is angle theta, right? It would say 10 over the sine of theta is the same thing as whatever this is over the sine of that angle. That's the law of sines. And then you can use the law of cosine. But I'm not going to use that now because you guys haven't seen that yet. I'm going to introduce any new trig to you. Alright?
If we did have that formula right here, could we use it?
Yeah.
Alright.
You got it?
Yeah.
Somewhere? Okay, where's that sheet come from? What is that?
Mrs. Spy in calculus, she makes us kind of learn it a little bit. The law
Okay,
of sines,
let me
stuff
see.
like
I'm just
that.
curious what it is.
Different stuff like
Yeah,
that.
these are your trig identities. Okay. Yeah. I don't see law of law of sines, right? I mean, law of sines, law of cosines. Yep. And I think that's, if you guys haven't seen it yet, I don't know which calculus that is.
Analytical geometry and calculus.
You know the pre-cal?
There's a brief description.
Yeah, trig. Okay. All right, gotcha. But if you know those tools, you can use those. Okay. If you don't remember that, what's another way to do this problem?
When I was doing it, was some cosine of the angle